Hi, Math 2 Enhanced. So this is page 11 of our packet. So let's take a look at number 6. It says to find the exact value of sine, cosine, and tangent at the 3 pi over 2 angle. So take a look at your unit circle on page 10. You'll find 3 pi over 2 is 270 degrees, and the coordinate at that point is 0, -1. So my x is 0 and my y is -1. So let's do my sine of 3 pi over 2, my cosine of 3 pi over 2, and my tangent of 3 pi over 2. So looking back at page 10, my sine of my theta is equal to my y value. So sine of 3 pi over 2 would be equal to my -1. My cosine of my theta is equal to my x value. So my cosine of 3 pi over 2 would be 0. Tangent of my theta is y over x. So in this case, in this problem, my y over x would give me -1 over 0, which is undefined. You can't divide by 0. Let's jump over and look at number 9, which is -pi over 3. So look back at page 10 at our unit circle. We can't really do this without our unit circle. And I need to go -pi over 3. So remember that would be clockwise. So looking at my unit circle, I can see that pi over 3 is at 60 degrees. So -pi over 3 would be -60 degrees, or down at our 5 pi over 3 on our unit circle. So at 5 pi over 3, let's go get our coordinate. It's +1/2 in the x direction and -rad3 over 2 in the y direction. So I'm going to do all the same things again. My sine of -pi over 3 is going to be equal to my x value, my y value. My sine of -pi over 3 is going to be equal to my y value, which would be -√3 over 2. My cosine of -pi over 3 would be equal to my x value, which is my 1/2. And now we're ready for our tangent. So remember our tangent of -pi over 3, if you want to put parentheses around this to keep the negative with the pi over 3, you can. It's not tangent minus anything. You don't want someone to think that. So the tangent is going to be equal to y over x. So in this case, that's equal to -rad3 over 2 divided by our 1/2. Remember, dividing by a fraction is the same thing as multiplying by the reciprocal. So this is really √3 over 2 times, and instead of dividing by 1/2, I'm going to multiply by the reciprocal. Let's flip it around. I'd get 2 over 1. My 2's cancel, and this simplifies simply to the negative square root of 3. Try 10 through 15 and check your answers in the folder. And if you have any trouble, please come to office hours. Next, let's talk about the new topic on page 11, and that is reference angles. So what is a reference angle? A reference angle, by definition, is the positive, acute, meaning less than 90. It's going to be a small angle, less than pi over 2. Acute angle formed between the terminal side of an angle and the x-axis. You're going to find as we do these problems, very common reference angles are going to be pi over 3, pi over 4, and pi over 6. That's our 60 degrees, our 45 degrees, and our 30-degree angles. So let's start with looking at an example of one in each quadrant. So number 1 is an example of a reference angle in quadrant 1. In quadrant 1, the reference angle, REF angle, is the angle itself. So in the first quadrant, whatever angle you have, so let's say pi over 6. So when we're looking at the angle pi over 6, then the space between the terminal side and the x-axis is really the angle itself. So if that's what the reference angle is, it's the angle formed between the terminal side and the x-axis. It's actually pi over 6. It's whatever angle you've drawn in the first quadrant. So it would be itself, pi over 6. So let's take a look in the second quadrant, something like 150 degrees. So 150 degrees in my second quadrant, and I want to find my reference angle. So first I need to think about where it's at. My reference angle is the positive acute angle formed between the terminal side and the x-axis. It's this blue angle right here. Well, because we know that a straight line has 180 degrees, we all know that this would be 30 degrees. But you can always find a reference angle in quadrant 2. So in quadrant 2, if you're working with degrees, it's always going to be 180 minus the angle. And if you're working with radians, it's going to be pi minus the angle. So let's take a look at something that would lie in the third quadrant. Negative 150 is something that lies in the third quadrant. So let's draw negative 150. Let's remember to go clockwise with it. So I'm going to go to 90 degrees. Then I'm going to go past that, almost 180, but I'm here at 150. So this is negative 150. Or another way to think about the same angle is that it's positive 210. Negative 150 degrees and positive 210 degrees. So let's think about what my reference angle is. So first of all, I'll talk about the word positive in a minute. It's the acute angle formed between the x-axis and my terminal side. So this is my terminal side, that's the x-axis. It's this little blue angle. So here's the deal. My reference angle is always positive. So I might have been moving in a negative direction, and you might think about that as being a negative 30 degrees in front of negative 180. But a reference angle is just always that measurement and positive. So my reference angle for this one would be positive 30 degrees. When you're in the third quadrant, so quadrant 3, some shortcuts to help you is if you're in degrees, you can do your angle minus 180. And if you're in radians, you can do your angle minus pi. That's always going to give you that smidgen that's left over there. However, that only works if you're thinking in terms of the positive angle. So I'm going to underneath here write positive angle. So what I mean is, I don't want to use the negative 150 minus 180 for my shortcut because that's, what is that? Is that negative 330? So instead, I want to use the 210 if I'm going to use this shortcut. 210 degrees minus 180 will give me my leftover 30-degree angle. Finally, let's look at an example that would fall in the fourth quadrant. So 7 pi over 4. If you need to look back at your unit circle, you're welcome to. But remember, it's being divided by 4. So I already have an idea that this is going to be my 45-degree angle in my fourth quadrant. It's positive, so I know I went this way with it. And this is my 7 pi over 4 angle. So now I'm thinking about what is my reference angle. Well, my reference angle is going to be the little acute angle formed between my terminal side and the x-axis. It's this little guy. So I need to figure out how much space is there. Well, you might be thinking, oh, when I go all the way around, I'm at 8 pi over 4. I'm at 2 pi. So I know that there's pi over 4 here. You can certainly reason that out on your own. There is a rule you can use to help you. That rule in the fourth quadrant is that your angle is 2 pi minus your angle, or it's 360 degrees minus your angle if you're in degrees. So let's take a quick look at that math, because sometimes we have trouble doing 2 pi minus a radian that's in fraction form. So let's see what that looks like. Let me grab my blue just since this is an aside. If I wanted to use my shortcut for this one, I could use 2 pi minus my 7 pi over 4. Again, I'm using the positive angle. Okay, so I can't subtract fractions unless they have common denominators, going all the way back to grade school. Well, this 2 pi is over 1. So a good common denominator for these two could be possibly 4. Okay, so I want to rewrite this as something. For my 2 pi, I want to rewrite it as something over 4. That means I have to multiply my denominator by 4 and my numerator by 4, and I would get 8 pi over 4. So now I can subtract because I have two fractions that have the same denominator. When you subtract fractions, you subtract the numerators and you keep the denominator. So this would give me 1 pi or pi over 4, which is the exact same answer I got when I just kind of looked at my graph and reasoned it out. So both ways work, and in both instances, I got pi over 4 for my reference angle. So let's take a look at number 9, because this particular problem, 660 degrees, I first of all need to be able to graph it to figure out where my terminal side is. So I know since it's 660, so it's something bigger than 360 degrees, I know it wraps around more than once. So I need to figure out where it ends so I can figure out where my terminal side is. So let's find out how many times it wraps around. So 660 degrees minus 1 rotation, 360 degrees, leaves me with 300 degrees. So this graph would go all the way around once, and then I need to go all the way around to 300 degrees, which is about right here in my fourth quadrant. So I'm going to go all the way around to where 300 degrees would be. So this is 660 degrees is what I graphed. But mentally, I was remembering that I went around one time and then I went to 300 degrees. So my reference angle is this angle that's in between my terminal side and the x-axis. Well, since there'd be 60 degrees here, because I'm at 300, if you will, to get back to my x-axis, I needed to go another 60 degrees. I could use my shortcut rule. Remember what the shortcut rule was? It was 360 minus my angle when I'm in the fourth quadrant. However, I can't use the 660 degrees. That wouldn't work. Instead, I'm going to use my 300 degree angle for my shortcut. I have to use my positive angle, and I have to use my angle that's in between 0 and 360. So this would be 360 minus the 300, and I can see that I have 60 degrees left over to get back to the x-axis. It would be my reference angle. You can do 5 through 8 and check your answers in the folder in our Unit 7 packet filled in. If you're having some trouble, why don't you come to office hours, and I would love to help you with it. Thanks.